We've learned how to use the digital write function to turn on and off Arduino digital input output pins. We've learned how to use the analog read function in conjunction with the analog to digital converter to sense analog voltages. In this video, we're going to talk about a function called the digital read function, which allows us to read the state of a digital input output pin. It'll allow us to determine if the voltage being supplied to that pin is high or low, 5 volts or 0 volts on the Arduino Uno. Okay? And while we're talking about this, we're also going to talk about how it's important to use what are called pull up or pull down resistors. All right, let's get started. On this breadboard, I got one of the circuits that's a schematic is given for this circuit in one of the handouts this week. So what I got here is a yellow or an orange wire connected to 5 volts, bringing 5 volts over here to the breadboard. And then this is connected to a 3.8 kilo ohm resistor, which is then connected back to the Arduino via the white wire to digital pin 7 over here. And then I got this black wire going back to ground. But this right here is a switch, and it's a momentarily on switch, which means its resting state is it's open. It's an open switch. So I don't have a closed circuit here. 5 volts is being supplied, but since this switch is open, there's no path to ground. No current's going to flow. And what that means is that this resistor isn't going to use any voltage. Voltage drop across a resistor is proportional to how much current flows through it. V equals I times R. So if I is 0, the voltage drop is also 0, which means when this switch is open and no current flows, the voltage on this side is 5 volts and the voltage on this side is also 5 volts. So we'd register 5 volts at digital pin 7 if we were to measure it. When I close the switch, you'll hear it click. When you close the switch, that provides a path to ground. Now current flows, the voltage drop across the resistor is 5 volts because this resistor is the biggest source of resistance in this circuit. All the voltage is consumed by that resistor, and now the voltage here is 0 volts, and that's what will be registered at pin 7 if we could measure it. Another way to think about this is that when I close this switch, I've shorted the white wire. It's now connected to ground, so it's 0 volts. But when the switch is open, it's connected to 5 volts. All right, let me write a sketch and show you how to perform what's called a digital read on digital pin 7, and I'll show you what happens when you press this momentarily on switch. Okay, so I got a brand new sketch here, and I'm going to set up get it started by creating a setup and a loop function for us. All right, here we go. Now I'm using digital pin 7. So I'll define a variable of type byte called my pin equal to pin 7. And then in the setup, this is the first time we've ever done this, but in here, I want to make this pin a input pin. So I'm going to set the pin mode on pin 7, my pin, as an input. And as I described in the handout, what this does is it sets this pin in a high impedance state. Think of it as having a really high resistance now, so it can sense the voltage at a specific point in a circuit without drawing any current because it has such a high resistance. No current flows into this pin, so it doesn't change the way the circuit behaves. It can just monitor the circuit. It's kind of like a digital multimeter in that way. All right, so I set that pin as an input. All right, and then down here in the loop, what I'll do is, one thing else I'll do is I'm going to create a serial connection between the Arduino and my laptop here at 9600 bits per second. And then down here in the loop, I'm going to do a digital read. But first, I'm going to create a variable, another variable of type byte to store what this reading is. All right, and then down here in the loop, I'll do a digital read on pin 7 and store the result in this variable called my reading. So what value is my reading going to be? Well, it's going to be either a 0 or a 1. It's going to be either low or high. And that's the only values it can be. So let's do an if-else statement. We'll do if my reading equals, double equals for compare, 0, we'll print the word low to the serial monitor. Else if my reading equals 1, we'll print high to the serial monitor. And I guess we'll do this. Otherwise, there's the possibility that there could be some sort of error, I suppose. So if there's something other than 0 or 1 on this digital read, we'll print error to the serial monitor. And that's it. Okay, so that's our program. Let's put a delay in here of 100 milliseconds just to slow things down a little bit so we're not screaming through this faster than we can print stuff to the serial monitor. Okay, so let me save this and upload this. And once it's uploaded, compiling. All right, so the sketch is uploaded. And so it's doing every 100 milliseconds, it's doing a digital read on my pin, which is digital input output pin 7, which is set as an input. Let's take a look at the serial monitor and see what we get. High, 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 high. So why is it's telling us now that the voltage is 5 volts at pin 7. Again, that's the effect of the pull-up resistor. With the switch, which is currently open, not conducting any current, there's no voltage drop across the resistor. So the resistor pulls the voltage up. It's a pull-up resistor. It pulls it up to 5 volts. Now, let me press the button. It goes to low. So now the voltage has dropped to 0 volts. High, low, high, low, high, low, high, low, high, low. Okay? So I could, let me stop this. I could reverse the order of the resistor and the switch in my circuit, and now then the resistor would be acting like a pull down resistor, which pulls the voltage down to 0 volts when the switch is open. And then I get exactly the opposite effect here. All right, but I won't do that. I think you could figure out how to do that. You just reverse it so that the resistor is connected to ground instead of 5 volts, and then when the switch is open, it pulls the voltage at the pin 7, down to 0 volts. Okay, so that's it for this lesson. All right, that's a quick introduction to digital read and pull-up resistors. Let me say one more thing. You can, it turns out the Arduino Uno, the microcontroller, the Atmega 328P, has internal pull-up resistors, and you can set them to be used. But I won't tell you how. You can look that up yourself. And that means that you don't have to have external pull-up resistors like we do in our circuit right now. But I wanted to show you what they are. I wanted to give you a little bit of more insight into what's going on with a pull-up or a pull-down resistor. All right, now you know how to use a push-button switch. You can use it to control stuff in your circuit.